Okay, so the third question is unique paths, which is a question of DP on grids. Um, so this problem can be optimized in the way that we can solve this problem using recursion, and to optimize this like overlapping subproblems, we can use DP. And even in DP, we can first of all do a tabulation, and that tabulation can be like further optimized into memoization, and that memoization can be further uh, optimized to using the space optimization. So what we can simply do is use a 2D DP array to keep track of overlapping subproblems and optimize the problem. And we can simply use the previous values, like the for example the previous rows values, to get the values for current rows, which is basically memoizing the values. And the last thing is, instead of using a 2D array, we can simply use um, a single array, or like two arrays, to solve this problem. So in this particular video, we will only be doing this problem using recursion and tabulation, and we will go through other methods, other optimizations in some other videos. Currently we are like only focusing on tabulation. So for unique path, let's understand the problem. For example, we have m3 and 7. Okay, m3 and 7. M basically means rows, and n basically means columns. Okay, so we have this 1, 2, 3, 4, 5, 6, 7. Okay, so currently the robot is standing over here. Where it wants to go is this. Okay, and how can we go? Basically, what I can simply tell you what the question basically means. This is a m into n grid, we know. It is present on the top left corner. I told you that 0 0 is the coordinate. Robot tries to move to the bottom right. I already told you that basically you have to reach there, and there are only two ways to move: either the right block or the like bottom block. Okay, you can't go here. This is not allowed. Okay. Now, given the two integers m into n, return the number of possible unique paths that the robot can take to reach the bottom right corner. Okay, got it. So basically, you have to dial like how many ways are there. For example, in this case, you are here, you have to go here. You can take this and this. This is one way. You can take this is like two ways. Okay. If I have, I'm here. I want to go here. So I have one, two, three, four, five. Okay, I think I missed. So let's say one. So I think this one is finished because there is no other way to do this. Okay, one. So two and three, right? Four, five. I think there are like five ways. Um, okay, let's see. Let's take a small example if there is one. Three and two. Okay, so we have three rows and two columns. So I have here, I'm going to go here. One, two, three. Okay, and do we have any other way? Nope, only three ways out there. Okay. Okay, so let's use another. So it was 3 and 7. Okay, so basically 1, 2, 3, 5, 6, 7. Okay, so I'm here. I want to go here. So at any point, I have two ways. Like either I can take this route or this route. Now, where you have to focus is these edges. Okay, so if I am over here, I only have one way. Okay, I can only go. So this also depends on like where I am going. So say I am over here, I cannot move to the bottom. I can move to the right. Okay, so the question is telling us to go to right or bottom, but we can also backtrack this, or rather than saying this is rather than calling it as backtracking, what we are basically doing is like, if suppose this was a path, what I'm doing is I'm starting from here. I am assuming that I can go here and here, which is like not correct, but this is not like wrong also, correct. So what I'm trying to do is I'm retracing the path that the robot okay um came from. So what I did was basically I assumed that I have reached, and then I tried to backtrack my path to the origin. Okay. So what you have to do is like, suppose you are moving from um, here to here. So at this point, you will not be able to go here. You can only go there. So this is like, there is only one way to go. Okay. So the count will be one if you are here. Okay. Got it. So if I'm over here, the count will be one again because you can't move to the right. Okay. And say I'm moving backwards, I'm retracing my path. So if I'm over here, I can move this side, but I cannot move up. Okay. And if I'm over here, I can move up, but I cannot move to the left. Okay. So these are like cases which can help you solve this problem. So what we have to do simply is, first of all, check for these conditions. If so, what I will be doing, so in this case I will be starting from m-1 and n-1, and I will be going to 0 0, basically retracing my path. Okay, so I will check. So I will be like moving in this way and this way. So either I am like doing j minus minus, or I am doing I minus minus. Okay, so in both these cases I will not hit, like I will not extend um, my pointer from the right side or from bottom, because I will be doing a minuses on both sides. So either I will be going to this in this direction or in this direction. Okay, so there is no possibility of any such behavior. So what you have to check is whether I am over here in this line. Okay, so how do I do that? So if the pointer is more than 0, okay, if in any case the pointer goes here or here, if the I is more than 0, or the j is not more than 0 but like less than 0, because less than 0, or like I am over here, j is less than 0, in both these cases there is no way. Okay, so this will return me a 0. This problem will return me 0. And say I have I is equal to 0, or I is equal or j is equal to 0. So if I am in this row, sorry, yeah, in this row or this column, so that basically means that there is only one way. Got it? So if I am over here or over here, I do not have any way to go to 0 0. And if I'm over in this row or in this row, I only have a single way to go. So I will simply return 1 and 0 in those cases. I will not solve anything. Okay, so these are like my base cases which will help me solve this problem. This will be like the smallest problem that there is to be solved. And how will I count my ways? I will simply do a left plus right. I will do recursive calls for the left, what do you say, left place, and not right, but like top place. So I will, if I'm over here, I will get the counts for this and this, and if I'm over for here, I will get the count for this and this, and this loop runs over till I am here or here or here. So if I'm over here, I will return 0. If I'm over here, I will simply return 1. So this will return 1. Okay. And say this also, this say this returns x. Okay, let's just, solve this problem. So I have 3 and this have, okay, so I'm over here. Okay. And I want to reach over here. So I start from here. Okay. At this point, what I am relying on is this and this. Okay. And for this, I'm relying on this and this. So this part we knew this will give me 1. Okay. This gave me 1. I'm relying on this only. For this, I'm relying on upper and this one. Okay. This one and this one. Now same thing, this will go until this is also relying on this and this. So since I'm over here, there's only one way, so this will return me 1. And this, if I'm over here, I'm relying on this and this, so this will return me 1, this will return me 1, so this is 2. Okay. This will give me 1, this is 3. Okay. And this will return me 1, 3. This will return me 1, 4. This will return me 1, 5. This will return me 1, 6. Okay. And this will return me 1, so 7. 7 over here. Okay. And this will return me the 3 and 6. This will return me 10. This will return me 15. This will return me 21. This will return me 28. So this will have all the counts. So the answer became 28. Okay. So if I look at its answer is 28. Easy peasy lemon squeezy. So in this one, 3, 2, I have do not save. The rows will be 3 and this will be 1. So this is 1. This is from here. I'm like retracing my path. So I want this and I want this. So this basically, this will give me 1. Okay. Because this has 1 and this also has 1. So this will give me 2. 1 from here, 2. And this will give me 1. So this will give me 1. This will give me 2. Answer will be 3. So I will have 3 ways to reach over here, which is the answer. Okay. So I'll just try to code this up. First of all, using recursion. Right. So the first thing that we do is simply the base cases. Okay. How do you solve the base cases? If I is equal to 0 or j is equal to 0. So I am sure we will not reach a point where I is less than 0 or j is less than 0, because like we are intercepting them right here. So this will return me 1. Okay. And we'll add that base case if this doesn't work out. But I think this should work. Okay. Now what we do is we will get the values for left and right answers. Okay. Left will give me, if I do this, paste it over here. Okay, so this will cause an issue because this is not the, so we'll require a helper function and a helper function with the coordinates. Okay, int j. So let's cut this, let's paste this. So initially First of all, I'll just write down the answer. I'll start from m minus 1. I'll go to m minus n minus 1. Okay. And the helper will do this. So it will just basically go to the left side for the left I minus 1. And for right, it will do a j minus 1. Okay. Now we will have to simply return the sum of these two. Okay, let's see. So these should give me the answer. Okay, there is a compilation error. Why? Because left and right are okay. I have added some, but it should be right. Correct. Oh, this should give me the answer. Okay, this worked, right? So basically, this works. Okay, so this gives me TLE. Basically, this does not work for a really big input. So what we can do is just solve the overlapping subproblems such that, like, if we have a combination that we have like seen previously, we can simply just use its value. So let's initialize a 2D vector, and it will have minus 1 initially. Let's give it the rows and the columns and initialize it with minus 1. Pass the DP over here. Pass to the function, and we have to pass it by reference because we cannot create a new copy because we will have to make changes in that 2D array itself. Okay, so we'll just check, have we seen this before? How we know like if we have seen this before or not? Simply check if we have like added some value. How do we do that? Basically, if it is not minus 1, basically we had added, then that simply means that we have added something. So if dpij is already been solved, if the value is not what we had initialized, just simply return the answer. We do not have to do the computation again. Okay, now in this case we will have to add dp and tp, and we will have to store the we will have to store the answer for ij if we did not have it previously there. So we will store it. Okay, and if next time same like issue comes up, same problem comes up, we will use it. Okay, so now it works. So this is like tabulation now. Okay, so this worked, right? And in this one we are basically covering all the indexes of the 2D array. So basically the time complexity will be of m into n, and since we are using a 2D matrix, the space complexity will also be of m into n. So I think I've run out of the quota. So if I try to look at the space complexity, is it there? I can relate with that statement. But yeah, so this can further be optimized uh, using like pre-computed values. Um, we don't have to like make calls. Um, yeah, so we'll like cover those optimization in the next videos. But for now, tabulation and recursion. That's all for this video.